All right, everyone. Hello, Jim Malis again. Let's talk about Chapter 9 for Physics 209 at UWM from the Katz book, first edition. All the problems we're doing are the first edition of the Katz book that I've done here, and all the problems that we're doing for 209. This is going to be Chapter 9, and there are, I guess, problems we'd like to look at. Chapter 9 looks a lot like Chapter 8. There are some chapters in the Katz book in their treatment of mechanics where the chapters sort of overlap, which kind of makes it somewhat convenient. I mean, sometimes it's a little bit confusing, but usually it's convenient. And so basically, a lot of the stuff that I said up to this point, the first 8 chapters, they follow really well into Chapter 9 at the very least. And later on, there's other things we can talk about as well. But so let's see how we're going to approach this, you guys. For Chapter 9, I'd like to try to do the following problems. Following problems from the Katz book. From Chapter 9, let me try to walk through problems 25, 30, problems 25, 30, 45, 45, 65, 81. Okay, see what we got. Let us try 25. Here we go. So problem number 25 from this chapter is saying that an object of mass m equals 5.8 kilograms moves under the influence of one force. The force causes the object to move along a path given by x equals 6.0 times 5.0 t plus 2.0 t squared, where x is in meters and t is in seconds. Calculate the work done by the force on the object from t equals 2 seconds to t equals 7 seconds. The best way to figure out the force that is being exerted on the object, you guys, is, well, first of all, the best way to find the work is find the force and find the distance. It's not always the easiest way to do this. This is a variable type. The force causes the object to move according to the following scheme, what x would be. So let us see what we can say here. I mean, they're basically trying to tell you this right here. They're basically trying to say that x 6.0 plus 5.0 t, I'm bypassing the zeros here. I'm not going to worry about significant figures, but I always try to take things as accurately as I can because the computerized system WebAssign that we're using in this particular case just really results on the accuracy being done. I'm not making a big issue out of significant figures, but on the other side of that, you want to be as specific and as accurate and as precise, I guess you could say, as possible when you're doing these problems till the very end. And if they ask you to round off, then round off. If they don't, then give a pretty complete answer there, and you should be in the ballpark of what they want. There is a 2% error tolerance on WebAssign that has been given, a 2% error tolerance, 2% up or 2% down for all the homework problems, all the exam problems that you're doing. So be aware of that, okay? I'll mention, that's going to be mentioned elsewhere as well, but you'll see me talk about that, and it's talked about right now, in fact. Calculate the work done on the object from t equals 2 seconds to t equals 7 seconds, I think it is, right? Okay. So what are you going to do here? Well, the way you want to look at it, there's a number of ways to go. It's kind of awkward the way it's set up. It's not as easy. I mean, we know that work equals force times distance. work equals force times distance. Yeah, okay, true. The problem is the force can be variable as we are proceeding along with time, as we are proceeding along the path. The force may not be a constant 100 newtons of force. It may be at one point 100 newtons of force, at another point 101 newtons of force, at another point 105 newtons of force, somewhere down the road 200 newtons of force. So I got to somehow, this is a calculus problem, whether it looks like it or doesn't, at initial glance, I guess you could say. M is 5.8 kilograms. We are told this for X, which is interesting because if that's the case, V is going to be dx dt. Now they're telling us it's going along the x-axis. They made our life easy. We don't have to worry about I hat, J hat, and K hat. We know everything's along I hat. It's going to go back, it's going to go one way or the other, or possibly back and forth, but it is on that line of action associated with I hat. Because the way they had said it here, guys, is, the force caused them to move, given by this, where X is in meters. Well, they haven't really said that. We're assuming that X is along the X coordinate axis. They haven't really very explicitly said that, but they've said it explicitly enough. We're okay. So if that's the case, you guys, that's the case, we got this right here. So V is this, that's dx dt. Let's get the derivative. The derivative of a sum is the sum of the derivatives. Derivative of the constant 6 is 0. Derivative of 5t with respect to t is just 5. The derivative of 2t squared over there to the far left is going to be 4t. All right, we got this under control right here. Fantastic. Tell you what I'm going to do. Why don't we find the acceleration, which is dv dt. Take another derivative. Actually, that's the same as the second derivative of the x function. If that's the case, the answer is 4. All right, 4, that says a lot. Okay, if it's 4, that's 4 meters per second Let us see what we can do. In this particular case, F is constant. If you really wanted to get rigorous about this thing, and let's do so, just to kind of cover ourselves. If you integrated from T sub I to T sub F, if you integrated from T sub I to T sub F, the F function times dx, but the dx is going to be dx dt, something like that. Let me see what I can say here. You got this here. Let me try to think exactly what we want to say. I did kind of let it go in a lot of ways here. Let me kind of go away from what I've done in the notes. I think my notes are fine, but let me be a little more rigorous. You saw what happened last time, and we can catch ourselves and others in mistakes, and others and we, each one individually, we all make mistakes on occasion. So we can catch ourselves, and we can catch others making a mistake too. I am looking at this, and I am trying to think what I could say here. What do you say? This is the acceleration, 4. Isn't force equal to mass times acceleration? Isn't force equal to 5.8 times the acceleration of 4? And this is meters per second. This is meters per second, and this is 5.8. Okay? This guy right here is going to be 23.2. So 5.8 times 4, 23.2 newtons. That's a constant force. It turns out it's a constant force because the mass is constant, ladies and gentlemen, and the acceleration is constant. If somehow there was a variable entity associated with mass and or acceleration, the force is a variable entity at that point. In this case, it's not. We're probably not going to need to do what I'm about to do. I'm kind of going on my own on this one. At t equals 2 seconds, at t equals 7 seconds, let's take it that way. This is 23.2. And this is, there's a lot of ways to go here. I just want to, I'm going to go this way, and then I'm going to go another way, in addition to going this way, I guess you could say. dx dt is the quantity 5 plus 4t. That's what dx dt is. dt is this, and this should be interesting. What we got here is the integral 2 seconds, 7 seconds. Let's see what we got. 5 times this is going to be 116. 5 times this is 116. So this times 5 is 116. This times that is going to be 92.8. T so we got this right here. If you actually do the integral, this is probably, I could say maybe the strictest way to do it. I think I opted to not go there, which, I don't know, in retrospect, I'm not sure that was the best idea or not. It's going to be this. It's going to be the same answer when I do this another way. But I kind of opted not to go there. So let's see what we do have. When you do this, you're going to get W is equal to just do the integral here, and that's going to be plus, and this is going to be half of that. It's going to be 46.4 t squared. And that's it. I mean, let's see how that works out. You actually do it, and again, I did what I did here. So let's see where this thing comes out to. You're looking at, I'm going to put a 7 in here, and I'm going to put a 2 in here, and we'll see where the whole thing's going to go, you guys. Let me get a calculator. I just didn't want to stay strictly with my notes. I didn't go this way initially. This is going to be the same answer when I show you the way I did it initially. But for the time being, let's take a look at what the heck is going on here. You could put a 7 in here and grind the whole thing out. So let's see what we got here. 7 in there. Okay, so it's 3,085.6 for the first guy, for when you put the 7 in there, minus, put the 2 in there, plus 4 times this, because you square the 2, you get 4. 46.4. Okay. So let's just see here. I don't want to play too many games with this. You got this. Sounds good. Do the subtraction. $2,568. With the other, now look, that's fine. Period. That's the answer. End of the story. Okay, let me just make sure I did that right. I got 2,558 in my notes. I must have made a relatively small error, but an error nonetheless. Let us just make sure that it is all okay. What must have happened? This just does not make any sense. I should be getting a different answer, but I am, so let me redo the part that I did with you guys. Let me plug in the values. Now there's another way you could have done it, and basically, now this is to me this is the best way to do it. Period. Best way to do it. Didn't necessarily do it in my notes initially, but I just did it now, and I think it's the best way to do it. You also could have done this. Because the force is constant, just find the delta x and multiply it by the force. The force itself that is constant is 23.2. Times, I'll put a time symbol here. I'm going to run out of room, guys, as you can see, but times what? Well, let's see where the heck it is. 2t squared for just some very strange reason here. I must have made somewhere a small mistake, but I'm not, for the life of me, I'm not seeing that small mistake here, to be honest with you. Let's see. Somewhere something is not what it should be. Shouldn't be an issue though. The math is correct. The math should work, guys. Let me just make sure I've not done anything very careless. I think it's okay, but let's have a look. So you got 23.2. Then you got, for just some reason, I got to see 652. 652. Okay. All right. So you got this. You got the x value at the value of t equals 7. This is the x value at t equals 7. And that's that. This is the x value at t equals 2. Just odd. I'm trying to put 2 and 2 together here on this one, guys. Why would it be off like that? It should not be off at all. It's somewhere I've done something. I'm trying to think. I'm gonna have to just double check the work here, guys. But I think there shouldn't be any kind of issue here. Just trying to think about it. All right, let's see what we got. We got 23.2. Times what I'm about to get here, and it better, maybe the notes might be wrong initially. Let's see what we got here. Well, first of all, the 6 and the 6. 6 minus 6 is 0, so don't even worry about that. This right here is 7 squared is 49, double it, you got 98. 98 plus 35, right? 98 plus 35 is 133. Here, you've got 10. This squared is 4. 2 times 4 is 8. 8 and 10, 18. All right, let's see what happens. This should not actually be an issue, but since it is an issue, I have to resolve the issue. Let's see what we have here. When you do this is 117. Let me just make sure I'm doing all the math right here. Yeah, sure. I'm not seeing anything wrong thus far. 2668. Yeah, same answer. Let us now see what the heck just happened. Let me recheck this, guys. I gotta recheck. There's got to be a reason. Don't want to do anything too careless here. 133. See here, 49, 98. If I take this here, I get 49, I get 98. 133 minus 18 is 115. 115 times 23.2. 2668. All right. Now it's starting to get interesting. That's what I'm getting here. And that is what I got here. There has got to be something going on here that I need to look at. Let me be careful here. Let's take this. Let me integrate this and get 5t plus 2t squared. 5t times this is 116t. So 5t times 116t. This is going to be 46.4 t squared. So that still should not have done it, but maybe it did. There might have been a problem right here, guys. No, 46.4 t squared. That is still not a problem. Let me look. Somewhere, something. Forgive me for doing this, guys, but I think we're going to come out stronger as a result of it. It's going to be 92.8. Half of that is 46. 92.8 is 46.4. Man, guys, it sure does look right. I mean, it sure does look right. All the way around, it just looks right. 46.4 for this. This guy right here, 116. Yeah, it sure looks right. Let's have a look, guys. There's got to be something up here. So we did what I did here and got this answer, and we should be getting the same answer right here, you guys, as we do this. There's absolutely got to be no difference. There's just got to be an arithmetic error somewhere. All the mathematics works. I'm just debating now which one's the arithmetic error. I bet you that is, but man, it sure as heck don't look like it, does it? Let's have a look. Aha. Got it. Yeah, this is fine. The top part here should be this. Let's just make sure we got that. Let's put that up here again. Got it here? No, there's something wrong here. All right, guys, I hate it when stuff like this happens, but it's going to happen sometimes. I'm confident we have exactly the right procedures. I'm absolutely confident if you do it the way I just showed you, the way I showed you to get down to here is right. I just think I have the wrong answer, but the procedure was right. So let's figure this out. This should be fine. Let's try it again. I think we got it. I think the way I had it. Make a long story short, the way I have it in my notes is correct. The way I'm showing it here is incredibly awkward. So let's get over the awkwardness of it. Let me put a t equals 7 right across the board here, guys. Put a 2 in here. There it is. Yeah, as I told you, there's no way that was wrong. This guy, the 232 plus 4 times 46.4. 417.6. It's going to be 100 bigger. I wrote the answer 2568. This right here, the subtraction is not 517.6, it's 417.6. So it'll be 100 bigger than 2568. It'll be 2668, which is the way I did it the other way. Okay, sorry. Guys, the procedure, I tell you, was spot on. I could not see any mistake in the procedure other than the fact that I made a careless arithmetic error, which is still an error. It's still wrong. Still wrong. Okay. We got it. We got it. So basically, guys, what you can do is you can do the calculus type problem. The force could be variable. The acceleration could be variable. If the acceleration is variable, the force is going to be variable. Or if the mass is variable, if the mass and or acceleration are variable, you can, some way or another, it is possible to have a variable force going on. Once the acceleration was found to be, 4 meters per second per second, 4 meters per second per second, the acceleration is 4 meters per second, and the mass is 5.8 kilograms, nothing changes. Mass times acceleration is 5.8 times 4, 23.2 kilograms meters per second squared. That's 23.2 newtons, constant force. How much distance is covered parallel to the force? The force is acting along a straight line parallel to the displacement. If that's the case, if it's parallel to the displacement, you are simply going to say, let me find out how much displacement took place, the delta x, and then go from there. And that's where this comes in. The force was 23.2. The delta x was what position would this thing have along the x-axis after 7 seconds? That's where the 7's right here. Great. what position would the particle have early on before it got to the 7 seconds when it was only at 2 seconds? Okay. Position here, the subtraction between the two is how much delta x it moved. The delta x is 115 meters. 115 meters times 23.2 newtons. 115 meters times 23.2 newtons is 2,668 newtons times meters, 2,668 joules. Period. End of the story. This is the way I did it in the notes. The answer is correct. The answer is absolutely correct on that one, the way I did it in my notes. I tried to show off a little bit and almost got burned for it, right? I said, yeah, you could also go here. You could also go here and say, okay, let's work with this. Well, delta x delta t is 5 plus 4t dt. Remember now, dt and dt cancel. You have your delta. dt and dt is your dx. So dx dt times dt, dx dt times dt is going to be the dx. Do a straight out integral here, guys. Here we go. Up here, then go here, then evaluate between the limits. Spot on. It's the same answer. Okay? If you don't make an arithmetic error like I originally made, it will be spot on the same. You can see it's the same answer. Okay. That is 25. Let us look at problem number 30 and go on from there. Okay. Let's talk about 30. For problem number 30, that's a neat problem. Problem number 30, a particle moves in the xy plane from the origin to a point having coordinates x equals 7 meters and y equals 4 meters. Under the influence of a force given by F vector equals 3y squared I hat plus xj hat. A, B, C, D. How does it go? A, what is the work done on the particle by the force if it moves along path 1? That's horizontal. What is the work done on the particle by the force F if it moves along past path 2? I'll draw these in a little bit, guys. And what is the work done on the particle by the force if it moves along path 3, given in green? So you got A, B, and then D. Is the force F conservative or non-conservative? Explain. If it were to be a conservative force, the amount of work done would be the same in all instances. We would determine that the work is the same in all instances if no matter what path I take, I get to the same value of work. Then it's a conservative force. It's a conservative force field that we're dealing with. If we get different answers, that force that was doing all this is not conservative. We're getting different answers for the work. If we're getting the same answers for the work, it's indicative of it being a conservative force. All right. Well, we try to do this in a careful manner, and let's see what we can say about it. There is let's make it look like that. Let me see what I can do. This is that's path 1. That's path 1 right there. You're gonna go here. You're gonna go here. This is trying to kind of debating here. What color chalk to use, guys? Just want it to be visible for you as well. All right, let me take a shot at it. That's path 1. Now let's just see how this goes, guys. They got different colors in the book, but that's not a real big deal. Path 2 is this. Just see how that looks, guys. Forgive me. Let me just see what that looks like. It looks okay. It doesn't look great, but it looks it's okay. It seems like the white's the most visible of all, but you can see those are two different colors, so that's okay. And then there's path 3. Just check, guys, really quickly here. Looking pretty good, pretty decent. Okay. You are essentially dealing with the origin here, which is 0, 0. Here, this is 7, 0. This is in meters. This is 7, 4 up here. And this is 0, 4 right here. Just kind of give you where the goalposts are in this whole thing, right? And they are telling you the force is 3y squared I hat three y squared I hat plus. It's a little strange. I mean, they can do anything they want with a function. The x, normally associated with horizontal, is now has something associated with a force and its direction associated with the y coordinate. The y, normally up and down, associated with vertical, has something associated with the horizontal sense. These are just numbers, guys, but the vectors are vectors. This is valid. You can write something like this and then talk about it. You know, they're just saying ABC. ABC is saying, find out what it is. You know, what is the work done on the particle by the force F? If it moves along path 1, shown in red, then path 2 shown in, well, they got different. They're calling different things. They got it shown in red, blue, and green. We're not worried. We are simply going to go and do the job. The work is going to be the following. It is going to be, you are going to take the integral, let's take 1. You are going to integrate along the x-axis. You're going to integrate along the x-axis, and then you're going to integrate along the y-axis. You're going to do x-axis, then y-axis, then go that way. So that's what you're going to do here. So you're doing that. Let us see how you want to do it. Let me see how I did it. Fascinating issue with the last problem that we had done, guys, just to kind of digress slightly. For problem number 25 that we had just done, you also could have done difference in kinetic energy. You could have found what the kinetic energy of this, probably the fastest of all of them actually, you could have found the kinetic energy that was attained after 7 seconds. You could have compared it to the kinetic energy that was attained after 2 seconds, done a subtraction, and you would have found the work, and it would have been 2,668 joules as well on that. You could have found the velocities. What do? You go, well, dx dt is the velocity. Dx dt at what point? Well, find dx dt, do the velocity function, x, get the first derivative, v is equal to dx dt, plug in t equals 7, that's the final velocity at that instant. Also plug in later on, plug in x, t equals 7, you get at t equals 7 the velocity, and then plug in t equals 2 and get the velocity at t equals 2. Go 1/2 mv squared in both cases, do a subtraction, and you'll get 2668. You'll get 2,668 joules that way too. That goes pretty fast. I've got that in the notes here, just so you know it. So you can look at that as well on Canvas. Whole bunch of stuff you can say here, guys. So let me see. And there's a lot. Like I said, guys, I have a lot more problems there for you, fully worked out, than I'm going to be able to do live, or somewhat live right now, right? Even if we were meeting together, even if we're meeting together in person, guys, there's not a whole lot more. You're not going to be able to do every single problem live, but you can show a lot of people how to do this stuff if you post the problem somewhere, give them access to these very many problems. Otherwise, literally, I don't know, maybe to do it in a very rigorous manner, I have no idea how long it would take. Probably numerous semesters just for the 1 semester class. So I like to post those for you and hopefully help you out. There are a lot of ways to look. Let me say something in general, and then maybe, so there's 3 different ways to get, look guys, let's make a really long story short. We're starting right here, and we're getting up here. We're getting up here in 3 different ways, but we're always starting at the same place and always ending at the same place. But there's 3 different paths. I wonder what the answers are going to be. There's a lot that goes on. There's a lot that can be said. I don't know how rigorous I want to get on the matter right now. I'll say this much. As a general rule, if you go from RI vector to RF vector, it really should be vector notation at that point. Let me not even put that on there, but they're vectors. It's F vector dot dr vector. And there's a whole bunch of crazy stuff that can happen vis-a-vis all that. I mean, if you're going to do that, let me just say this to you. I mean, you're basically going from here to here. I showed this in the notes. Like I said, sometimes people write it more rigorously in some circumstances than in other circumstances. F vector is F sub x I hat plus F sub y j hat plus F sub z k hat. Well, if you want to go 3-dimensional space. They're not really doing 3-dimensional space here, but if they did, they did. This right here, the dr vector, look, man, there's a lot going on here. Remember, r vector is x I hat plus y j hat plus z k hat. If you do a time derivative, that's v vector. Great. Let's talk. I mean, we can say a whole bunch of stuff here. If you do this, you got dx dt I hat plus dy dt j hat plus dz dt k hat. Yeah, it's true. If you multiply by dt on each side, you'll get, multiply by dt on each side, you'll get all the way across, ladies and gentlemen. You get this, and I've seen this written various ways as well. So, dr vector is this. So if you're dotting the dr, if you're doing that, if I'm making this claim, okay, if I'm making this claim, and I am, certainly am, dot dr vector dx I hat plus dy j hat plus dz k hat. Wow, what a mess. Yeah. See how slick you guys are. Do you remember some time ago at this point, if you're following these videos in order, you don't have to. You do what you want. You could stick with the stuff that I've got online written old school. That might be more time efficient for you. Maybe watching some of the, it's not as effective time-wise. You can always back stuff up. You can always speed up. You can always see what's going on there. I'll try to give you some decent foundation for what's going on, at least give you some index so you can look at various topics. But that's up to you what you want to look at. You just look at the notes and not look at the film. But if you're looking at the film, do you remember what I did earlier? Do you remember that? Do you remember that A vector dot B vector is... well, it's a lot of things, is what it is. We know that. We also know that it's AXI plus AYJ plus AZK, and I don't, whatever. This is an option to go this way, I guess. You got this right here. That's a dot product, not a straight out multiplication like we're used to seeing. All right, be patient with me, guys. I'm flying around with different chalk here, trying to figure out what's optimal for you and me. We said that. Yeah, right. And when you do that, we said that's AX BX, that's AY BY, that's AZ BZ. True. It becomes a scalar. It's a weird looking thing, almost like it's made up. It's like, wow, gee, hey, what do you think? That looks like it should work. Yeah, it not only looks like it should work, or maybe it does look like it or doesn't look like it. Doesn't matter. It does work. It's true. A vector dot B vector, there's some beautiful mathematics that proves it, not necessarily very difficult. There's a lot of beautiful mathematics out there. Much of it is not incredibly difficult, but even the stuff that's not much incredibly difficult is usually much incredibly tedious. There's a lot of tedious stuff out there to do to get it there. The math itself, not necessarily really difficult, very oftentimes not very difficult, but very tedious, and you got to pay attention. And that's not our business right now, but this is what you get for an answer here, guys. At the end of the day, this is what you got for an answer. So, AX plus BX, AX plus BX plus AY plus BY plus AZ plus BZ. What the heck does all that mean? Well, let's kind of bring it down here to a culmination, I guess you could say. All of that comes out to, if you're doing the dot product, ladies and gentlemen, you're going to pretend that these are the A's, these are the B's, and you got it to be that. At the end of the day, it's going to be this. and how that plays out. I mean, that's its own issue how it's going to go here. Let me kind of leave it as, okay, guys, I'm just not incredibly comfortable how this color is going to look for everyone involved. Let me do this. I'm trying to save some of the multicolor stuff here to make it look a little bit easier to deal with. Here goes. It's kind of a loaded statement right here, guys. Let's figure this out. It's going to be fx dx plus fy dy plus fz dz. Well, I'm not dealing with z's, but if I was, here it is. What you can basically do at that point, guys, is you can say that w equals the integral from xi to xf fx dx plus the integral from yi to yf fy dy plus the integral from zi to zf fz dz. You can break them up, guys. The integral of a sum is the sum of the integrals. So it's quite the adventure, I guess you could say. It's not that. I mean, it's easier done than it is said than it is written down. But this is really the way you're going to play it for all three of those integrals, and then you're going to for all three of those integrals, except for the of the three integrals. Basically, you could play that for all integrals. The other one is a little different story, but not too far off. It essentially comes to this level as well. Okay. All right. There's a lot here. There's obviously a lot here, you guys. So let's, without further ado, let's get through it. All right, guys. Sorry about that. I got to pick and choose all this. In all these years of teaching, I've taught at another place as well, and they call me the chalk man there. I think you're starting to see why. But there it is. We got some of the stuff here. Let's talk. Let's get to it. Let's get to it. What's essentially going on here for path 1, the work is going to be 2 scenarios. Now, I already told you the integral of a sum is the same as the sum of the integrals. So let me do the sum of integrals here. Let us take a path. Let us take us walk. Y equals 0 throughout, and you're walking from x equals 0 to x equals 7. But from x equals 0 to x equals 7, but y is equal to 0 throughout in this whole process. So here goes. X starts at 0, and y equals 0 throughout on this whole thing here, guys. So I'm just going to worry about the x's. I'm going to go to x equals 7 right here, and then I'm going to go, and let's just write the stuff down. Let's see. I'm going to write down what they gave to me, and then I'll see what kind of games I can play. Now, when you're integrating, you treat letters like they're constant if you're integrating with respect to other variables. If you're integrating with respect to other variables other than the variables that are present, the variables may be present, but if you're not integrating with respect to the variables present, those variables get treated like they're constant numbers. Okay, so you've got this. I said y stays 0, so I don't know, I wrote it a little differently on the other place, but I'm going to go from, well, wait a minute, time out here. Here, x is, now once you've gotten all the way to here, bam, all the way to here, x equals 7 is a constant. That stays. Y equals 0, and then you're going to climb from y equals 0 to y equals 4. And you're doing 3y, well, you're doing the same thing you've always done. The function is what it is. So, let's go. Let's do a dot product. Well, this is dx I hat plus dy j hat, but the dy j hat, the dy is 0. There is no change in dy, so it's 0 j hat. So when you do the dot products, you know, this is very strange now, guys. Whenever you do dot product of two things that are the same, you get 1. When they're different, you get 0. You get 0. When they are, as I said, when they're the same, you get 0. When they're different, you get 0. When they're the same, you get 1. Otherwise, you get 0. 0. 0. So here we go. Yeah, if they're the same, otherwise, so what you're doing here is j hat dot I hat is 0. J hat times j hat is 1. At the end of the day here, you're getting this integral. We'll get the right limits when it's time. At the end of the day, you're getting this integral. You're getting x dy. So you take this guy here, and the dot product here is 0. The dot product here is 1 times dy, or x dy times 1. And you got this. You are going to take, for x equals 0 to x equals 1, when y equals 0. Well, I'm not going to sweat y equals 0. I don't need to put a y equals 0 in here. I just need to take this and do it. You treat the x like it is, you treat the x like it's a constant. The other one, let us see what we just did here. Let me just right. That would be, I just did it here for the second one. Let me put the first one up here. Let me just put this kind of in a different order, you guys, if you don't mind. Let's play the game. On the I side, you got this. I hat dot I hat is 3y squared dx. I hat times j hat, forgive me, I hat dot I hat is 1, so it's 3y squared dx. I hat dot j hat is 1. I hat dot j hat is 0, actually, so you're done. That's the integral from x equals 0 to 7. That's the integral from x equals 0 to 7. they're telling me y equals, they're telling me but y equals 0. That's pretty significant. We'll cross that bridge in a little bit. The other one is saying j hat times I hat, 0, j hat dot a hat. J hat dot a hat is 0. J hat dot j hat is, you got y equals 0 to y equals 4, x equals 7, x dy. Okay, what's going on here? All right. Well, it's not that bad. I mean, because this stuff's a lot easier done than said. I think when you see it in my notes, you'll follow it probably a little easier. You don't have to look at it on, sometimes looking at something on camera is easier. Live is the best, obviously. But sometimes looking at it on paper on at your own pace is one of the best ways, actually. Let's see what we got here. We've got this plus that, okay? This y equals 0 is really setting off some alarm bells, I guess you could say. So we'll figure it out. If y equals 0, you can do a lot. I mean, well, y equals 0 is a constant situation here. Put y equals 0 right. Put y equals 0 right here. Well, here's 0. 0 squared is 0 times 3 is 0. I am integrating. I am integrating from x equals 0 to 7, to x equals 7, where y equals 0 dx. That's interesting. Basically, that amounts to 0. It amounts to some constant c, but the difference, the constant c being here at 7 and that same constant being here at 0, when you do the subtraction, that right there, all of this goes to 0. Let's do the second one then, and maybe that's our ticket out of this thing. Y equals 0. We hope we get something for all this work we're doing on it. X dy. X is equal to 7. So let's take a look at that right here, this guy. What's left here is just figuring out what this guy is, okay? All of this. Well, put x equals 7 right here. Y equals 0 to y equals 4. Integrate. Here's 4. Here's 0. Four times 7 is 28. There it is. It's a long song and dance, but we got there. 30A, that's going along path 1, was 28 joules. Let's find B. B is saying, find what's going on with path 2. Take the walk this way and that way. Let us see how we're going to do that. Okay. For B, let's take the walk again, guys. I mean, we got, essentially it's going to come out to 2 integrals again. So let's actually cut to that chase right now and make ourselves. We are talking about, for this case, you're going to climb with an x value staying at 0 and the y values vary. So the x value stays at 0. Maybe that would have been an easier way for me to write it from the get-go. You go y equals 0 to y equals 4 of 3y squared I plus xj. Well, we already said that. 3y squared I plus xj. Yeah, we said that. We said that. Yeah, right. Dot, how are we going to do this now, right? I mean, we're basically going to go on the upside. You're doing. I might depart a little bit from the notes here, just for the heck of it. Dx I hat plus dy j hat. Okay, you're going to see what I'm doing in a second here. The other one is saying then go horizontal. Once you get up here, so you went x equals 0 and you let the y vary. Here you let y remain unchanged, y equals 4, and now let the x vary and do the integral. So here they're saying keep y equals 4 as a constant, then go from x equals 0 to x equals 7. And that's 3y. It's a little departure from my notes, not much, but dot. All right, I mean, you can see this is its own little. This stuff's easier done than said. Just writing the stuff down and not getting confused by it is the hardest part. This is the best way to write it. Now, we know that when you do a dot product, there's a lot going on. Let's do it. I'm departing. I think I took a little bit of a shortcut in my notes, and I didn't want to do that. At least right now, I don't want to do that. This is at x equals 0. Okay. This is at x equals 0. I hat dot I hat. Three y squared dx. The other one is j hat dot j hat, and that's x dy. Okay, true. When you put x equals 0 right here, this whole thing goes to 0. And you're just talking about this. For the other guy, you got y equals 4 here. That's dx. Now for this one, you're going to do, let's figure this out. Let's make sure I didn't do anything too crazy here. Right. Correct. X equals 0. And you're trying to do, let me just see here, guys. I just don't want to do anything too crazy here. You're looking at this. Right. So the y varies here, and that's what the y varying, you guys. And we can see here, for some reason I just want to make sure this is coming out of here. X equals 0 and you're going up here. There is no change. There is no delta x taking place, you guys. There is no the change in x is not occurring. There is no change in x occurring here. X is equal to 0, so there's no change in x occurring. So this whole thing vis-a-vis what you're doing here is not going to work. You got it's x equals 0 throughout the climb. X equals 0 throughout the climb. Well, if I integrate 0, I get a big fat 0, or I get some constant. Well, a constant minus the same constant when I'm doing the two limits, whatever they may be, a constant minus the same constant is still 0. So this is going to be 0. This is going to be 0 also because when it's climbing, you guys, yeah, I know y is changing. I get that. Dx is not changing. When you're climbing, there's no dx going on this way. So you can be faithful to the mathematics here, but there's no climb going on here. All of this, all of that right there is a fat 0. Y equals 4, go all the way across. Let's do it. Y equals a constant 4, go x equals 0 to x equals 7, then ride all the way across, you guys. What you end up getting is here, now remember, there's going to be, you do this, you're going to get 4 terms, but the I hat dot j hat and j hat dot I hat are 0. They got to be the same. I hat dot I hat is 1, j hat dot j hat is 1, k hat dot k hat is 1. So you're just going to get 2 items here. Take a walk. Dx I hat, 3y squared I hat is 3y squared dx. The other one is x dy. Again, this guy's going to go to 2 places, but the I hat dot j hat is 0. This guy is going to go to 2 places, but the j hat dot I hat is 0. So it's just going to be like and like. I hat dot I hat is this. J hat dot j hat is this. So that's what's going on here. Now, is there going to be any issues here? Y equals 4 tells me something. X, the dy ain't changing. There's no change in dy once you've reached this altitude. Once you've reached that altitude, you ain't climbing up and you ain't falling down. dy is 0. I mean, you're not really, if y is equal to 4, it ain't going anywhere. So this guy's out of there. This guy does have significance. You're going to put y equals 4 right here. 4 squared is 16 times 3 is 48. Y right here, that's a 4. 4 squared is 16 times 3 is 48. Let's go. 48x go 7 times this. Put a 7 in here, and you should get 336. Put a 0 in here, you should get 0. Already there's some issues, but the reality is what it is. Yeah, it's what it is. It's what it is, and they are different. A and B are different. There's already an issue here. This is not conservative. This force ain't conservative. So we got it. We're doing pretty good. Okay, that third one. Third one should be interesting. Already we know this is not a conservative force with which we're dealing. How would you get 3 though? 3 is pretty crazy. 3 is interesting. 3 is a little, it's essentially the same as everything that I've been telling you thus far about vectors. But you better be very careful. So let's see. So what do we got here? We will show two approaches. And I give two approaches to this thing. I don't know that I can show you, given the time constraints we got, the two approaches on this, but let me kind of opt for what I think is the better one of the two. I mean, they're all good. Yeah, it's I don't know, it's pretty fascinating stuff. I mean, if you ask me, it's really fascinating stuff. Maybe we should look at two ways to get C. We already got A and B, and we don't necessarily like what we see, but we do like what we see at the same time because we did it right. Well, they're not the same amount of work. You start from one place, you end at the exact, you start at one place and you go to another place to finish. You start at one place, you finish at another place, and I took two paths starting from the same place and then finishing somewhere else at another same place. They both start and stop at the same places. And yet the amount of work required to accomplish task one compared to accomplishing task two is different. This is task one, this is task two. All right. I said I was going to use two approaches for C. What the heck? That might be a good idea, actually, because it is a fascinating problem. I think it's going to help you. The big thing is, look, I'll tell you what I'm going to do. Let's parameterize the situation. When push comes to shove, let's put in another variable, but this variable is sort of, kind of a dummy variable. It's a variable that will act in a manner that is proportional to the situation, or the situation will utilize, if you allow me to give anthropomorphic qualities here to this whole situation, the problem will utilize the new variable in a way that is proportional to all the ratio of the speeds that are going on, the speed at which things are occurring. This is easier done than said. We'll show two approaches here. We will parameterize. Let's introduce T. It doesn't have to be time. It could be time. It could be time. Where, and this is all in my notes, guys. So if we, let me not, I don't want to go incredibly crazy with this. Let's go from 0 to 1. I already told you that that measuring stick determined by measuring from 0 to 1 is kind of the measuring stick of everything that goes on in mathematics, or at least everything I've seen. At the very least, there's an incredible amount of great mathematics and application that absolutely uses that. That absolutely uses a measuring stick from 0 to 1. All right, well, let's figure this out. Just want to make sure I want to say this right. If I want to go here from 0, 0 to 7, 4, that means I want to walk 7 over and also walk 4 up. I guess if it was a line, the slope of the line containing this line segment right here, the slope of the line containing this line segment, the slope of that line would be the rise over the run, would be a rise of 4 divided by a run of 7. 4 divided by 7. Interesting. What the heck do we mean by that? It means this. Means this. If we want to talk about R vector being, now R vector, guys, is going to be along this line. Okay, along this line. Do you understand if you run a certain distance? Let me figure this out, how I want to say this. If I were to run, this is almost easier written down than easier said than done. Let me say this, and then we can all react as to how we feel about it. How's that? I am going to use that so-called dummy variable of t to try to get me here. I want to stay along this line. Does everybody understand what I'm saying here? This guy right here is the new R vector. That's the R vector going that way. That way. R vector goes along that line. May I ask you a question? If you put t equals 0, what's 0 times 7? 0. What's 0 times 4? 0. At t equals 0, you're right here. If you put t equals 1, 1 times 7 is 7. 1 times t equals 1, right? T equals 1. 1 times 7 is 7. 1 times 4 is 4. 1 times 7 is 7. So 1 times 7 is 7 over. 1 times 4 is 4 up. What if you put a half in there? 7 times a half is 3.5, and then 4 times a half is 2. You'd be doing this. Here's 3.5, here's 2. If you did 3/4 t, you'd get 3 right here, and then 3/4 right here would be 3/4. You guys, do you understand? You're getting similar triangles everywhere. I didn't draw that last one too good, but you're getting similar triangles everywhere along this line. There's a lot of ways you could write it. Whole lot of ways you could write it. So, if that's the case, this is how it plays out, you guys. You could say, okay, dr vector dt is 7i hat plus 4j hat plus 4j hat, right? Yes, true. And if you multiply by dt on each side, you get 7i hat plus 4j hat dt. Okay. Yeah, that sounds pretty good to me. I think this is the way you got to take it. I think this is the way you're going to take it. You're basically going to say, hey, look, haven't we talked about this? Haven't we said some stuff already? Didn't we say that W, let me not put limits on this thing yet. Let me just say this. Did we say this? For right now, just for the sake of understanding, assuming all the limits are appropriate and what they should be, right now, let's just talk. Is f vector dot dr vector going to be W? Okay, yeah, it is. Can I ask you some more questions? Is it true this guy right here is the same as f vector dot dr vector dt dot dr? Let me see how I want to write that exactly. There's a lot of ways you can write it. I don't know that one's exact. I don't know. I'm not sure one's better than the other, to be honest with you. But yeah, we've been there. We've been there. Okay, if that's the case, let's take a walk. From 0 to 1 is the t's, guys. T equals 0 to t equals 1. Here goes. F vector, they gave us this at the beginning of the problem, ladies and gentlemen. Dot 7i plus 4j. So there it is. There it is. Well, again, you got to remember what's what. You know, is this believable? Yeah, it's pretty believable to me. We kind of said, guys, that x is going to move at the speed of 7t. y is going to move at the speed of 4t. Maybe that's a better way to say it. Maybe initially I should have said it that way. So you got to remember, guys, you were saying this at the beginning. Whether we confess it explicitly or not, we're saying r vector equals xi hat. R vector equals xi hat plus yj hat. X is 7t. Y is 4t. Is that believable? Who's running faster? How much faster is he running? Who's running faster? Well, if we're going to treat the line as a race, and I was shining a strobe light, if I was shining a light straight down onto the x-axis, and then elsewhere simultaneously, I'm shining a light onto the y-axis. As this guy climbs, he's moving a lot faster in the x direction than he is in the y direction. How much faster? He's covering in a time t with t equals 0 to 1, that great measuring stick, 1, of length 1. From 0 to 1, as we run, this is going 7t. What does that mean? In time t, you'll go 7t. In the same time t, you'll go 7t in the x direction to the right. In that same time t where you went 7t, you went 7t in the x direction to the right. In that time t, you went 7t. In that same time t, you'll go 4t up. After t equals 1 second, you've gone 7. After t equals 1 7, you went 4 there. One's going at 7t. One's going at 7t, and the other one's going at 4t. That's pretty interesting. What the heck does that mean? That means this. The change in the y. I mean, how do they work change-wise? Well, delta y over delta x really? Delta y over delta x, delta y would be 7t2 minus 7t1. You start at t1, you end at t2. The other guy is 4t2 minus 4t1. Okay. That's 7 t2 minus t1 over 4. 7 times the quantity t2 minus t1, 4 times the quantity t2 minus t1. The difference here is delta t. The difference here is still delta t. Delta y over delta x is the slope of the line. It happens to be, well, here I'm sorry guys, I used delta x. I just found delta x over delta y. I didn't want to do that. But you get the argument. Let's go. Let's start that over. Y is this, so let me write it over here so it's a little less confusing. Y equals 4t and x equals 7t. Yeah, let's just stay with that. Let's go right here then. Let's just go right here. Delta y over delta x is, this guy is going at, it's 4t, so 4t2 is where he went after time t2. Here's where he started at t1. The other guy starts at, so this guy started at t1, 4t2, ended at t2. T1 start, t2 end. 4t2 is the location in the y direction at time t2. 4t1 is the location in the y direction after 4t1. 4t1 is earlier. Same argument here in the x direction. What we got Yeah, true. That's the same as, we said what we said. That's the same. T2 minus T1 is delta T. T2 minus T1 is delta T. That's 4 over 7. That's delta Y over delta X. Sorry, guys, I had it reversed. I was giving you delta X over delta Y. It is the same logic. It is the same logic. But, you want to get the slope here. The slope M is delta Y over delta X is 4 over 7. Are you telling me that if you're doing y equals mx plus b and the y-intercept is equal to 0, the y-intercept is equal to 0, y equals mx, y equals 4/7 x. What does that mean? That means if you go a total distance of 7, 7 and 7 cancel, and you're up high at 4. If you go 7 over, 7 times 4 over 7 gives you 4. If you go 3.5 over, 4 over 7 times 3.5 is 2. If you go, wherever you go, this right here gets you there. And this is actually useful in doing the problem another way. It is about speed. It is about the speed at which we are moving relative to particular reference frames. This guy, the shadow right here is moving very fast compared to the shadow right there. How much faster is it moving? 7 over 4 times faster. How many times slower is this guy moving compared to that? The reciprocal of 7 over 4, which is 4 over 7. And that's what I wrote here. That's what I was kind of trying to do over here, and I almost got in trouble doing it. But the big thing is, the speed is this. The climb, it'll climb 4 units for every 7 units of run. If you climbed 2 units, how far did you run? Well, how about 2 over 3.5? 2 divided by 3.5 is the same as 4 over 7, et cetera, et cetera. How about you climbed only 1 rather than 4? Well, it's 1/4 of this, 1.75. You only ran 1.75 to be able to climb 1, but you did run further. You ran 7/4 further to climb. If you climbed 1, if you climbed up 1, you would run 7 over 4. So on and so forth. Pretty big stuff. So I'm taking a lot of time on it. I mean, obviously the problem can be solved a lot easier, but I want to talk about this stuff. I think it's important to talk about this stuff. So there it is. I mean, there it is. So you're looking at something like this. Y equals 4/7 x. I'm going to come back to that, and I think you're going to like it. We said a lot. We've seen a lot here. Let's stay with this. Let's stay right here, right now. We'll take a walk. We'll take a walk a little bit later. Pretty neat stuff. I mean, so let's not I don't want to overwhelm the situation here, but let's get rid of a few things. And you just saw what I did. I'm going to utilize what I did to give you another look at what's happening here. We are talking about the speed at which components are moving. The speed at which components are moving. It's like me saying I am going to run across campus diagonally. What is my northward component of, what is my eastward component of speed compared to my northward component of speed? I'm running diagonal this way. Let's say I got a good path to make it and go straight. What is my x component that way toward the lake, and what is my y component there? Well, if I go at a 45-degree angle, the shadow moves the same speed either x or y direction. If it's a 30-degree angle toward me here as I'm running that way, it's going to be a smaller number, so on and so forth. Okay. So you do a lot of this stuff. Do the dot product, do the whole thing here. This is important enough, guys. I'm sorry, I don't want to just leave it. I don't want to leave it alone. Again, if you do multiplication here, and you will do multiplication for the dot product, you can if you wish. It is a binomial times a binomial. You're going to get 4 terms. 2 of those 4 terms are going to be I hat dot j hat, which is 0. And the 2 of those 4 terms are going to be the following. They're going to have an I hat dot j hat term, that's 0. And they're going to have a j hat dot I hat term, same kind of thing, and it's also 0. Only I hat dot I hat, which is 1, works, and j hat dot j hat equals 1. That also works. All right. Therefore, 7i dotted with 3y squared I is 21y to the 4th, 21y squared rather, I'm sorry. For that, this one right here, when you actually do it, you are going to get here and here, right? It's going to be 4x. That's it. dt. Yeah, there's a problem here. I thought you said you were going to play this game with t's. Yeah, I did. And I also said that y is going to be in this race where we look at the speeds. We are looking how fast everybody's moving. How fast? This guy's going at speed of 7. This guy's going at speed of 4. He's 7 over 4 times faster. The other way around is 4 over 7. This guy is 4/7. This guy is 4 divided by 7, the speed of x. Yeah, that's why he doesn't climb as high. When this guy runs 7, the other guy only climbs 4. He's only going 4/7 the speed. Let's talk. Y is equal to 4t. X is equal to 7t. Okay, we've already delivered that speech. dt. All right, it's going to be a long song and dance, but it shouldn't be too bad. 4t squared is 16t squared. 16 times 21 is 336 t squared. Four times 7 times t there it is. Well, yeah, yes and no. Now do the integral. Okay, like I said, I'm not thrilled erasing any of this, guys, but I got to erase something. All right, you saw the speech that was delivered. So, for better or worse, hopefully it's helpful at some level, guys. Hopefully for better. I mean, we look at it, do the integral. The integral of a sum is the sum of the individual integrals. The integral of a sum is the sum of the integrals. Here goes. This guy right here, what is it? It's going to be t to the third divided by 336 divided by 3, which is going to be 112. So it's going to be 112 t to the third. The other one's going to be half of 28, which is 14 t squared. looking good. Well, at least 0 and 1 makes life somewhat easier, right? You put a 0 here and a 0 there, 0 in both cases, it's just 0. Put a 1 here, you get 14. Put a 1 here, get 112. That's it. I mean, you get 126 joules. Yeah, this is a non-conservative force on steroids. I mean, there's no way. I mean, there's no similarity anywhere here. We're getting answers. They're all valid. But nobody's getting there. A is 28. B is 336. C is 126. Not conservative. Let's just get to the issue here. Non-conservative force. Have to be the same for it to be an indication of it. Even if they were the same, it might be fortuitous. It's got to always be the same in all circumstances, and that's not guaranteed. The other approach for C was you could have done something like this. Let me kind of get us out of the woods a little bit on this one, if I can. What do you want to say? Well, I had to convert using parameters. Remember now, I had to not forget that x was equal to 7t. X was equal to 7t, y was equal to 4t. I get that. X was equal to 7t, y was equal to 4t, and then I can do the dance. I could have gone right here, right off the bat. X equals 7t, y equals 4t, the quantity 4t squared. Go there and then go by t. I didn't do that. I put x's and y's, and at the end I plugged in x equals 7t, and y equals 4t. It doesn't really matter. I got to ask you something. Is there another way out of this? Yeah. That right there, exactly how I want to say this. If x equals 7t, can I ask you a question here, guys? Let me just ask it this way. Let's use x as the way to go. May I ask you a question? Did we already kind of determine that y was equal to 4/7 x? Every time there was an x, if you multiplied by 4/7, let me ask you a question. Here's x. Why don't you multiply by 4/7 and see what happens? 7 cancels and you get 4t. Wait a minute. That guy's y. That guy's 4/7, and this is x. Y equals 4/7 x. If I go dy dx, I get 4/7. If I multiply by dx on each side, dy, if I go dy dx, I get 4/7. If I multiply by dx on each side, I get 4/7 dx. Ladies and gentlemen, take a very close look at that. That's our way out. You could have looked at this and you could say, okay, what is he doing? Can you do this thing and say that w is going to be the integral, and I'm not going to put limits yet. I'm not going to put limits on it yet. It's going to be 3y squared I hat plus x j hat x equals 4/7 the dx rather is just dx, and that's an I hat, and the dy is 4/7 dx, j hat. This is another way of parameterizing what you're doing. It's another way of parameterizing what you're doing. This guy moves in the dx direction. This guy moves in the dy direction with this kind of a speed. 4/7 the speed of this guy. This guy's 1. This guy's 7/7. This guy's moving at a speed of 1. This guy's moving at a speed of 4/7. 4/7. Well, if he covers a distance of 1, this guy's covered a distance of 4/7. If this guy's covered a distance of 7, this guy's covered 4/7 times 7 is 4. If he covers 7, the other guy covers 4/7 of that 4. Is that true? Yeah, if he covers 7, the other guy covers 4. So you can kind of set it up like that. And then you could say, well, what are you talking about? Well, you could say that W, do the dot product business, guys. Do the integral with the x's. Through the integral with the x's, the x's are going to be 0 to 7 is the x's. Do the dot product. 3y squared dx. The other guy is going to be x, and this is also 0 to 7. Wait a minute, you said it was 0 to 4. No, I'm saying I'm going to use the parameter to be everything in terms of x. Everything in terms of x. So this guy's 4/7. 4/7 x. 4/7 x dx. So what are you talking about here? You got one more thing to do. Didn't we say dy was 4/7 dx? This guy's dy. I get it. But didn't we say that's dy and y is going to go 0 to 4? Yeah, but what is that in terms of x? Dy is 4/7 dx. See, it would have been just x times dy, but x times dy is 4/7 dx times x. And you're going to 7. What are you missing? Y equals 4/7x. Y equals 4/7x. So y is 4/7x. What's 4/7 x squared? It's 16/49 x squared. Y right here is 4/7 x. Square 4/7 x and get 4/7 x, the quantity squared, is 16/49 x squared. 16/49 x squared times 3 is 48/49 x squared. X squared. Plus, since everybody's going 0 to 7, put this guy here. That's 4/7 x. dx. dx becomes the parameter. You scaled everybody to the speed of this guy. Well, how fast is this guy? This guy's 1-on-1 right here, and here, this guy in relation to his speed is 4/7 of the speed. Y here is 4/7 x. Here, x equals x. This is just 1x. This guy's going 4/7 the speed of that guy. That's why dy is 4/7 dx. That's why dx is just dx. Don't know if that helps. Hope it helps a little bit, guys. So deal with it as we look at it. See what we got here. We got, if you integrate, you got the thing being 16 over 49. You got 16 over 49 x cubed. You've got the other guy being 2 over 7 x squared. You're going from x equals 7, x equals 0, x equals 7. Let's go the easy way first. Put a 0 right here, guys. Put a 0, x equals 0. 0 cubed is 0 times this is 0. 0 squared is 0 times this is 0. Good, it's out of there. Put a 7 in here. 7 cubed. 7 times 7 times 7. Well, two of those 7s, 7 times 7 is 49. Bam, cancels. I just got one 7 left over. 7 times 16 is 112. So if you do this, this is 7 times 7 times 7, which is 343. 49 goes into 343 7 times. 7 times 16 is 112. 7 right here. 7 times 7. One of the 7s cancels. 7 times 2 is 14. That looks awfully familiar. 112 plus 14 is 126. And that's what we got earlier. You may want to look at this as I got it written down. It's not going to maybe not going to be as chaotic as as me yelling at you the whole time here. Different paths yield different integral values. Therefore, the integral is not path independent. Therefore, f is non-conservative. Okay? So that's that. All right, guys, let me see where we are. So this is 25 and 30. Let me come back and do that. I don't want to be talking forever on this video. I'm going to start a new video. Let me do 45, 65, and 81 the next time we get together. All right, guys. Hope it's okay for you. I mean, it's all over the place, but by its very nature, it's got to be all over the place. It's there for you. You know how to look at it, slow things down, speed them up, do what you got to do if you want to look at the video. The notes you can kind of do at your own pace, and you don't have, so you might like that more. So whatever. But you got the. I try to complement it with that. These are good notes to have in front of us, guys. We will do the next time we get together 45, 65, and 81. I'm gonna leave this up here, and I will talk to you guys soon.